I'm going to show you an example of how to complete the square. First, let me tell you why you would want to complete the square. So you have an equation such as this, and you realize that you can't factor it. If you can't factor it using integers, and the biggest exponent is a 2, it means it's a quadratic, and when that happens you can complete the square. The whole goal of completing the square is to take the first two terms in this and to manipulate it so it's 3 terms, and those 3 terms combined make a perfect square trinomial. So the first thing you want to do is separate those first 2 terms from the constant. Separate them, meaning putting some space between them. Then, like I mentioned a moment ago, you want these 3 terms here to be a perfect square trinomial. So to complete the square, as it's called, you take half of the coefficient of x and you square it. So half of 7 is 7 over 2. Squared is squared. Notice I didn't do any arithmetic, I just wrote 7 over 2 squared. If that simplified to something nice, I would just write down whatever that is. That does not simplify to be something very nice. You can't just add to an equation 7 over 2 quantity squared. You have to balance it. So I'm going to also subtract from this 7 over 2 squared. By doing that, what I have done is I have rewritten the problem. I haven't changed its value because I've essentially just added and subtracted the exact same number. As I mentioned before, these first 3 terms end up being a perfect square trinomial, which factors into a binomial squared. It's going to be a sum because this middle term is a plus, so it's going to be a plus between here. The first term is the square root of this first term, which is an x. The second term in this binomial is the square root of 7 over 2 squared, which is just 7 over 2. I'm subtracting 7 over 2 squared, so if I bring that down and I want to get rid of the squared, so I'm going to actually square the 7 and square the 2, get 49 over 4. I'm going to have to add to this 9. To add 9 to a fraction, I need common denominators, so I'm going to change the 9 to 36 over 4, same thing as 9, and then of course this is equal to 0. At this point, solving the equation for x is going to be much easier than it was originally. Let's combine some like terms. So I get x plus 7 over 2 squared, and then I'm going to add the fractions minus 49 over 4 and plus 36 over 4. It's going to give us a minus 13 over 4. Our goal is to get x by itself, so we're going to add this 13 over 4 to both sides of the equation. If we do that, we get the sum of x and 7/2 squared equals 13 over 4. Next, we're going to square root both sides of the equation to get rid of this squared. As we square root both sides of the equation, since we're doing it to both sides, it's going to be plus or minus. We only want to put the plus or minus on one side of the equation. Both sides is not necessary. We want to put it on the side that doesn't have the x on it. So that's why I wrote it over here on the right. Now on the left side of the equation, the square root symbol and the squared are inverse operations, leaving us with an x plus 7 over 2 on the left. On the right, bring down the plus or minus. When you square root a fraction, you square root the top and the bottom. 13 is not a perfect square. Leave it in a radical. 4 is a perfect square. Its square root is 2. To get x by itself, I'm then going to subtract 7 over 2 from both sides of the equation. There are like terms on the right side of the equation, and they have the same denominator, so it's going to be negative 7 plus or minus the square root of 13 over 2. If I put that into my calculator, this that you see here is exact answer. It's 2 exact answers, really. If I want approximate answers, I put this into my calculator. One of those would be negative 7 plus square root of 13 divided by 2. The other one would be negative 7 minus square root of 13 over 2. I would get negative 1.69. Scratch that. I would get negative 7.0 around the 2 decimal places. And then I would also get negative 5.30. Check to make sure you got that in your calculator. It would give you that answer. And if you didn't, it's because you probably left off parentheses around the entire numerator. There's more than one term. Also, this 13 inside the radical, your calculator likely gave you a parenthesis at the beginning. You need to make sure you put one at the end also. So that is how you complete the square.